Hello, welcome to the second installment of the Chapter 21 lecture videos. This installment is going to cover flow rates, which begins at the bottom right-hand side of page 325, and it's very quickly going to move to page 326. So flow rates describes certain common pharmacy calculations used in the preparation of IV infusions. So when we talk about flow rates, we are talking about IV infusions. These are compounded solutions that provide fluids, specific medications, nutrients, electrolytes, and minerals to a patient. So precise calculations are required to ensure the right speed at the right strength and for the right amount of time. Some of you that have been in the program for a moment should still be familiar with the 5 patient rights. And you see we're covering 3 of those just by making sure that our calculations are correct and precise. So flow rate duration, and this is getting into page 326. This is going to refer to the length of time over which an IV will be administered, or how long an IV bag will last before it must be changed or before it needs to be pulled altogether. So they give us an example here to start with of a 1 liter IV bag is being administered at a rate of 200 ml per hour. And they're asking the question, how long will this IV bag last? And you see they've got the beginnings of a equation worked out there. And this is example 21.6 there on page 326, if you're trying to follow the slides. So we're setting up the problem, and then we are going to cancel out like units and or numbers. So you see we have the 1 liter that we started with over 1. We know that for every 1 liter, we have 1,000 milliliters. So they have 1,000 milliliters over the 1 liter. And our equation or our information told us that this was being infused at a rate of 200 ml per hour, and asking us how many hours was this going to last, or how long will the IV bag last. So they've got those equations set up there. We could cancel out liters from the first and second fractions listed there. And then mLs gets canceled from the second and third fraction listed there. Technically, you could cancel out the 1 hour, the 1 for 1 hour, because of the 1 from the 1 liter in the second fraction. And it's still just going to leave you with 1 times 1,000, which is still going to equal 1,000. You see where they've carried that down. And then for the denominator, 1 times 200 is going to equal 200. So we're left with an equation that reads 1,000 over 200. And if we divide 1,000 by 200, it gives you the answer 5. And hours was the only unit of measure left after you had canceled out your like units of measure. I apologize. So before we move forward into that next slide that I accidentally just revealed, let's look at example problem 21.7. Worked out on the board, so maybe this will make a little bit more sense. I know sometimes this is a little muddled trying to figure out with what. So example 21.7 there on page 326 provides a scenario of a 2 liter IV bag is to be administered at 250 ml per hour. How long will the IV bag last? So we're going to start out setting this up much like the example from 21.6. We're starting with a 2 liter IV bag, right? 2 liters over 1. We know that for every 1 liter, we have 1,000 milliliters, right? And we're being told that this is being administered at a rate of 250 ml per hour. It's 250 ml per 1 hour. So that is what your initial equation should look like. I apologize. I see that glare is kind of hitting. That's 1 hour under that glare box right here. 1 hour, in case you're having a hard time seeing that. I apologize for the glare. We are having to do this step right here, by the way, because your rate is provided in milliliters per hour. And you have to convert from liters to milliliters. That is the whole point and purpose for this middle fraction being in your equation, in case you were wondering. And we're only doing that because we're starting with liters. So next thing we need to do is cancel out our like units. So we can cancel the liters, we can cancel the mLs, and we can cancel like numbers, as I was just mentioning in the last one. Here we have a 1 liters, we can lose the 1 for that. So that leaves me with 2 times 1,000 for the numerator, which equals 2,000. And then for my denominator, I'm left with 1 times 250. So it should bring you to 2,000 over 250, and that's a 5, I apologize. So 1,000 divided by 250 equals 4. And this is 4 hours, because that's the only unit of measure I had left. So it would take 4 hours for that to run. I'm sorry, my calculation is incorrect. I must have typed in 1,000. If you divide 2,000 by 250, it should actually give you 8. I apologize about that. And again, that's still going to be hours. 8 hours. I do apologize. Let's look at another example since I muddled that one up just a tad. On textbook page 327, example 21.8. We are given a scenario that a patient is set to get a 500 ml infusion of cimetidine in lactated ringers, 5% at 10 a.m. The bag is to be administered at a rate of 125 milliliters per hour. What time will the infusion be completed? So let's just start with what we have based on what they're looking at. We have a patient that is set to get a 500 ml infusion. So there is your quantity, 500 ml. That's your starting amount. We're going to set that over 1. Again, I apologize about the glare, but that is 500 mLs. And we are also told that the bag is to be administered at a rate of 125 ml per hour. 125 ml for every hour. Now, I don't need that middle equation because we're not going from liters this time. We're already in milliliters. My rate is in milliliters, so I can just simply do the math. First thing we need to do, though, is cancel out our like units. And we can cancel out our like numbers. It leaves me with hours, which is what I'm headed for, right? And there's really basically not a lot of math left to do. All I'm left with for my numerators is 500. And the only thing I'm left with for the denominator is 125. So 500 divided by 125. That is 4 hours. That's how long it's going to take for that infusion to process. That is not what our question asked, though. Our question told us that the patient was set to receive this, or it was set to begin at 10 a.m. At what time will the infusion be complete? So if we start this at 10 o'clock in the morning, what is 4 hours later? Well, 11 o'clock, 12 o'clock, 1 o'clock, 2 p.m. That's supposed to be the @ symbol, and it did not go well. So that infusion would be complete at 2 p.m. Let's go ahead and look at the next example, 21.9. Example 21.9 says we have 3 1-liter IV bags that are to be infused at a rate of 150 ml per hour. How long will these 3 bags last? So this time we're going to start with bags because that's what we have, right? We have 3 bags. We know that each bag has 1 liter. We also know that for every 1 liter, there are 1,000 ml. And we are also told that this is being infused at a rate of 150 ml per hour. 150 ml per 1 hour. And so how long will these 3 bags last? So there's your equation. 3 bags over 1 times 1 liter per 1 bag times 1,000 ml per 1 liter times 1 hour over 150 ml. So we can cancel our like units. We'll lose bags. You lose the liters. We can even lose the milliliters. It leaves us with where we're going, hours. I can also cancel this 1, and we can cancel these 1s. It leaves me with, for the numerator, 3 times 1,000, and that equals 3,000, right? And on the denominator side, it leaves me with 1 times 150, which equals 150. The 3,000 divided by 150 equals 20. So it would take 20 hours for all 3 of those bags to be infused. That making sense? Let's look at example 21.10. So example 21.10 on the bottom right-hand corner of page 327 provides a scenario of 2 liter IV bags containing heparin, sodium, normal saline are set for administration at a rate of 250 ml per hour at 7 a.m. That's when it's set to begin. And it's asking, when will both bags be completely administered? So again, we're starting with bags because we have 2 bags, right? There's my 2 bags. I'm going to set that over 1. I also know that each bag contains 2 liters. That's 2 liters for each bag. I'll also know that for every 1 liter, we have 1,000 ml. And my scenario told me that this is being infused at a rate of 250 ml per hour. So for every 1 hour, we have 250 milliliters. Again, I apologize about this glare. That's 1 hour. 1 hour sitting under that glare box. So let's cancel our like units. We'll lose bags. We can lose liters. We can lose milliliters. It leaves me with where I'm going, hours. I can also go ahead and lose this 1 and that 1. And that looks to be it on this one. So for the numerator, I'm left with 2 times 2, which is 4. 4 times 1,000 is 4,000. For the denominators, I'm left with 1 times 1, which is 1, and 1 times 250, which is 250. So 4,000 divided by 250 . equals 16 hours. Now, remember, our question actually asked, when will both bags be completely administered? We were told that they were starting at 7 a.m. So if this started at 7 a.m., 16 hours later would put me at what time? 12 hours later would be 7 p.m., right? Another 4 hours later would be 11 p.m. So those two bags would be completely administered at 11 p.m. I'm sorry, 11 p.m. So that was flow rate durations that we have just covered. I hope this installment of the video, Chapter 21 video collection, has assisted you with mastering these skills. As always, I'm available to you. You just simply have to reach out to me if you feel more help is needed or you're still not clear on something. That's what I am here for. So I hope you have a great day, and until we see each other again, bye-bye for now.